boy, diamonds are very, very, of course, valuable gem. And in fact, we could say a lot about diamonds. This table right here, in fact, gives us the weight, which in diamonds are weighed in carats, and the actual value. And here is what we want to do. We want to find an exponential model for this data, and then use the model to estimate the weight of a diamond that's worth about $6,000. So you can see the table sort of ends right before 5,000. But assuming that this data is going to be modeled with an exponential function, the question is, can we find that function, and then can we use the function to then extrapolate and say what's going on when we have a $6,000 diamond, what would its corresponding weight be? Okay, well, a wonderful way of dealing with this sort of complicated diamonds data is to actually take out a computer or a graphing calculator and actually use it to produce what's called exponential regression in order to figure out what is the exponential function behind the data. So exponential regression means trying to fit the data with an exponential function. So how would you use the graphing calculator to do this? Well, we have the data, and the first thing we do is we enter each of this information, this data, and this data into two lists. So we enter that into two lists, and then we would actually do an exponential regression to get the equation. And so the equation would look like for this data, if you were to plug it through, and I'm doing it there live so you can actually sort of see how it would look real. But the thing we would get, I should use a diamond color, would be that the value given the weight would be 935.67 times 1.52 to the W power. Okay, now where do we go from here? Well, what I want to do now is I want to see when, in fact, what the weight is when this value here, when the value is equal to $6,000. So I want to make this $6,000, and I want to find out what W is going to actually make this equal 6,000. So we've seen this before. What we do is we'll call this W1. So we'll enter this function for W1, and then we'll actually enter the constant function for for Y1. So we call this Y1, this function Y1, and then Y2 on the calculator will be the constant function 6,000. And then we just graph them, and we look for the intersection. Now, I want to show you the graph of them. So here is the graph of them. Okay? And then what we want to do is we want to adjust the window to see the point of intersection. And you can see that point of intersection right there. And now we can actually find what the value for W is at that point of intersection. And if you read off there at the screen, you can see it. We see that it's approximately 4.44 carats. And so there's the answer. So you can see the power of the computer actually really allows us to focus in on even diamonds. Even diamonds.